So the proteins, since they are charged molecules or charged species, when they are subjected for electrophoresis, they move from one electrode to another electrode. Okay, so based on the difference in the rate of movement, again the lipoproteins can be divided into 5 different types. So based on centrifugation or based on electrophoretic mobility, we can divide lipoproteins into 5 different classes: chylomicrons, VLDL, IDL, LDL, HDL. These are the 5 classes of lipoproteins. So what are they? Chylomicrons, very low density lipoproteins, intermediate density lipoproteins, low density lipoproteins, and high density lipoproteins. Clear? So these are the 5 different classes of lipoproteins, and they are named so because from the name itself you can understand. A very low density lipoproteins, that is, they are having least density. Then there is an intermediate density. Then there is a low density. The highest density lipoprotein we call it as HDL. Clear? So which one will be forming the bottom layer when we are centrifuging this plasma, lipemic plasma? The HDL forms the bottom part, while chylomicrons forms the top portion, because the least dense lipoprotein is the chylomicron, because it is rich in triglycerides. And as we all know that chylomicrons are responsible for transporting the exogenous TG, that is the TG that is derived from the dietary sources or from the intestine. The triglycerol is transported to the liver with the help of chylomicrons. So because of the same reason, chylomicrons are having the largest quantity of TG, right? And because TG, the lipoprotein protein part of course is there, but the major portion of the lipoprotein is made up of triacylglycerol. So TG, we know that they are weightless. So lipid content density kornju varum. As the lipid concentration increases, the density decreases. It is in the inverse proportion. So HDL, in the case of HDL, the least, it is having the least quantity of fat or TG, right? While chylomicron is having the maximum quantity of TG. So chylomicron forms the top layer, while HDL forms the bottom layer. Right, so these are the 5 classes of lipoproteins, and along with all these 5 lipoproteins, we also take free fatty acids also under the lipoproteins, because free fatty acids, as the name indicates, they are free fatty acids. But being fatty acid, they cannot be simply transported. Even though we call it as free fatty acid, they will be loosely bound to albumin. So that is a protein which transports free fatty acids from various areas of the bodies. Clear? From or in between various areas of the body. Free fatty acids are not bound to any apoprotein. Clear? They are not having any apoproteins, but free fatty acids are loosely bound to the principal protein of the plasma, which is the albumin. So it is, since it is also bound to protein, we also group free fatty acids under the lipoproteins. But actually free fatty acid is not a lipoprotein. Clear? So that is the introduction of lipoproteins. So lipoproteins, the lipids absorbed from the diet and synthesized by the liver and adipose tissue are transported among various tissues and organs with the help of a class of molecules known as lipoproteins, because they are lipids as it is insoluble in blood. So in order to make them miscible, or in order to make their transport in an easier form, the lipids are bound to apolipoproteins to form lipoproteins. So lipids are insoluble in water, and this problem of transportation is solved by associating this non-polar lipids with amphipathic lipids, that is the phospholipids and cholesterol, and proteins to make them miscible in water. And lipoprotein is defined as a biochemical assembly that contains proteins and lipids. So lipids combined with proteins are known as lipoproteins. So the protein part is known as apolipoprotein. And the protein serves what is main function of the protein? They emulsify the lipid molecules. So many enzymes, transporters, structural proteins, antigens, and toxins are lipoproteins. Now, what's the structure of a lipoprotein? We have already told lipoprotein consists of a non-polar core and a polar exterior, right? So the exterior part is made up of phospholipids that is partially miscible, right? That is both, it is having both the polar part and the non-polar part, phospholipids and cholesterol, free cholesterol. That forms the exterior portion. And along with this phospholipids and free cholesterol, it's also having apoproteins bound to them, right? The non-polar lipid core consists of TG and cholesterol esters or esters of cholesterol, and they are surrounded by a single layer of amphipathic phospholipids and cholesterol, free cholesterol molecules. And they are oriented in such a way that the polar group faces the exterior while the non-polar portion faces the interior of the molecule. And the protein moiety of the lipoprotein is known as apolipoprotein and simply apoprotein. Apolipoprotein is otherwise known as apoproteins, right? So this is kind of, it is having a single layer, only a single layer of phospholipids and free cholesterol, and within which they accommodates the cholesterol esters. Kind of cholesterol, this is free cholesterol, right? With the OH group facing outside and the steroid part facing inside. While this is a cholesterol ester where the OH H is replaced with the fatty acid. The fatty acid, the tail. Clear. So this is structural difference between free cholesterol and cholesterol esters. And these are the TGs, right? And this is a peripheral apoprotein. This is the difference between peripheral apoprotein and integral proteins. This is an example for an integral protein, the integral protein. So different types of apoproteins in the Apo A, B, 2, A, B, C, D, E. No, types in the peripheral apoproteins example are A, C, and E. ACE. ACE. A, C, E are examples for peripheral apoproteins, while integral proteins examples are Apo B48, B100. Cellular types of Apo A can also access integral proteins. Clear. So this is the phospholipid. This is a free cholesterol, right? This is the TG. This is a cholesterol ester. This forms the general structure of a lipoprotein. So some apolipoproteins are integral and cannot be removed, whereas others can be freely transferred, and they are known as peripheral apoproteins. Now classification. They are classified into different types based on their difference in density during centrifugation. So based on density, they are separated by, that is flotation constant. Flotation constant കൂടുന്തോറും എന്താണ്ടാവുക ഒരു float ചെയ്യല് കൂടും. So chylomicrons will be having the greatest or maximum flotation constant. So based on the flotation constant during ultracentrifugation, they are divided mainly into chylomicrons, right? Chylomicrons are found during the intestinal absorption of dietary fats, right? It is having a density between or less than 0.95 and a diameter between 100 to 500 nanometer. At least what is the function of chylomicrons or from where they are derived. They are synthesized. Chylomicrons are synthesized by intestine. Chylomicrons are synthesized by the intestine. Now the second lipoprotein next to chylomicron, below to chylomicron is a very low density lipoprotein. They are synthesized by the liver and they are exporting the endogenous TG. Okay, then comes the intermediate density lipoprotein. They are derived from the very low density lipoprotein. During the metabolism of VLDL, some TG will be removed. So that what happens, density increases. Current TG കൂടുന്തോറും density കുറയുക ചെയ്യും. But TG കുറഞ്ഞു കഴിഞ്ഞാൽ എന്താണ് density കൂടും. So during the metabolism of VLDL or from the VLDL metabolism or from the VLDL, we can synthesize IDL. The body synthesizes IDL by the removal of small portion of TG. So intermediate density lipoproteins are synthesized from the catabolism of VLDL. Then comes a LDL, low density lipoprotein. It's also known as bad cholesterol because the LDL, the function of LDL is to transport fat from liver to tissues, peripheral tissues or extrahepatic tissues. Clear? And it is synthesized again. The final stage of catabolism of VLDL ends up with the formation of LDL. So the VLDL goes on undergoing catabolism. Once its half-life is over, what happens? Half-life no real, survive in the time. VLDL slowly start removing the TG. Clear? So the size will be reduced, right? So VLDL will be reduced in size to give rise to IDL, and from the IDL it will be synthesizing LDL. Then comes the last class of lipoproteins, which is a HDL or high density lipoprotein, which is having the least quantity of TG and is also known as good cholesterol. So LDL is the bad cholesterol, while HDL is the good cholesterol, and they are responsible for transportation of cholesterol. Cholesterol transport carry out in lipoprotein ആണ് HDL, and it transports cholesterol from the peripheral tissues to the liver. That's why it is known as good cholesterol. Okay, so LDL transports cholesterol from liver to extrahepatic tissues, while HDL transports cholesterol from extrahepatic tissues to the liver, and is having the highest density. So this is the a separation of different types of lipoproteins during centrifugation. Okay, so this color indicates the phospholipid concentration, right, and protein concentration. The yellow color indicates the TG, and the brown color indicates the cholesterol and cholesterol esters. Okay, so see, chylomicron is having the least phospholipids, clear, and the apoproteins, and hence it has the maximum, then the least density or maximum flotation constant. While as you come down, VLDL is having slowly its phospholipid concentration is getting increased, while the TG is slowly getting reduced. Cholesterol esters remain in the middle. And VLDL, when it undergoes catabolism, it gives rise to IDL and LDL. See, LDL is having more and more quantities of phospholipids and proteins, while the TG content avada koronu, pakshe cholesterol content avada koodi. And the dark brown koodi, light brown avada kornu, or yellow color is diminished. Now HDL nokiyokku, it's having the least quantity of cholesterol and TG, while it's having the maximum quantity of proteins and phospholipids. So it is the good cholesterol, while LDL is the bad cholesterol, because it transports cholesterol from liver to extrahepatic tissues, while HDL transports cholesterol from extrahepatic tissues to the liver. Now this is the electrophoretic pattern. That is when serum sample is applied. So this is the origin. That is, this is the site where we apply the serum sample. ഒരു ഡൈ യൂസ് ചെയ്തിട്ട് ലൈക്ക് ഓയിൽ റെഡ് ഓ പ്രോട്ടീൻസിന്റെ അല്ലെങ്കിൽ പ്രോട്ടീൻ സെപ്പറേഷൻ നമ്മൾ നമുക്കറിയാം പ്രോട്ടീൻസ് ഒക്കെ കളർലെസ് ആണ്. അപ്പൊ നമ്മൾ സെപ്പറേറ്റ് ചെയ്യുമ്പോൾ നമ്മളൊരു ഡൈ യൂസ് ചെയ്തിട്ടാണ് സെപ്പറേറ്റ് ചെയ്യുക. ഡൈ സ്റ്റെയിൻ. സോ വി യൂസ് ഓയിൽ റെഡ് ഓ. Clear, that's a stain which is used for separation, right, of lipoproteins. So sample, the serum is mixed with this stain and is subject for electrophoresis. So it is moving from cathode to anode. That is, we know the proteins are having negative charge. So that protein which is having the maximum negative charge will be moving at the fastest rate. അതായത് protein content ഏറ്റവും കൂടുതലുള്ള ആളാരാണോ അവരായിരിക്കും ഏറ്റവും സ്പീഡിൽ പോവുക, right? So this is the origin of application, and the serum is applied, and current voltage is applied, right? Sample apply ചെയ്തു, current കൊടുത്തു, switch on ചെയ്ത് കഴിഞ്ഞിട്ട് it is kept undisturbed, right? Electrophoresis during we power കൊടുത്തു കഴിഞ്ഞാൽ we should not then disturb the electrophoretograph. So after 2 hours, when you take the slide and observe it, you can see 5 different bands which can be found separated from the serum, and the first band will be seen in and or around the origin itself, and that forms a chylomicrons, because it is having the least protein content. അതുകൊണ്ട് തന്നെ സ്പീഡും ഏറ്റവും കുറവായിരിക്കും. പ്രോട്ടീന്റെ ക്വാണ്ടിറ്റി കൂടുമ്പോഴാണ് മൂവ് ചെയ്യാനുള്ള ടെൻഡൻസി കൂടുക, കാരണം പ്രോട്ടീൻസ് ആണ് ചാർജ് സ്പീഷീസ്, നോട്ട് ദ ലിപ്പിഡ് മോളിക്യൂൾസ്. ക്ലിയർ? So chylomicrons, being the least protein content, will be seen in and around the origin only, while it is followed by IDL. IDL is followed by LDL, right? Then VLDL. Sorry, ഇവിടെ ഇത് തെറ്റാണ്. Chylomicron will be followed by VLDL, then comes the LDL, then comes the HDL. So HDL is the fastest moving lipoprotein because it is having the maximum protein content. Okay, so that is how we can identify the different classes of lipoproteins. So based on their size, chylomicrons, VLDL, LDL, and HDL. IDL അങ്ങനെ പറയുന്നില്ല എന്നേ ഉള്ളൂ, പക്ഷെ IDL is there. Okay. See, these are the concentrations of different components of lipoproteins. Chylomicrons has 90% PG, only 5% cholesterol and cholesterol esters, and 3% of phospholipids, only 2% of apolipoproteins. VLDL 68, 5, 40% apoproteins. See, this is the composition.